Hello all, welcome to this class on elements of mechanical engineering. In this course, we are currently studying the fifth module, which is Introduction to Automated Systems. And in this class, we are going to discuss the topic sensors and actuators. Now, today we are going to see what are different sensors and actuators that are being used in automation. Previous class, we have seen what is automation, what are the different components of automation, and how open loop, closed loop systems are studied and how they work. And in this class, we are going to see sensors and actuators which are used in automation. So, we'll see first what is a sensor. A sensor is a device. It must collect the data from a manufacturing system, and this data is used for modifying the program in the controller. So we have studied what is a control system. A control system is nothing but which controls the actual manufacturing system. This control system uses some kind of program or numerical control. So for the control system to work properly, it needs some data like the output, whatever the machine is giving output, or whatever the machine parameters are changing from time to time. These points or these data has to be supplied to the controller. So for that, we will use sensors. To implement the process control, the computer must collect data from transmit signals to the production process. The information can be continuous or digital. So sensors can be collecting data in two forms. One is analog and second one is digital form. So the measuring devices will have two parts. Any sensor will have two parts, like first one is sensor and second one is transducer. So sensor is the device which detects the physical variable like temperature, force or pressure, etc. So whenever we have a sensor in the system, this sensor will detect the temperature. Best example for a sensor is thermistor, which is used in air conditioning systems. So in air conditioning systems, the thermistor will detect the temperature, like what is the surrounding temperature of the area. And similarly, force or pressure can also be detected by using different kinds of sensors. And here the second component of the measuring device is transducer. So transducer, that it converts the physical variable into electrical voltage. Now we can see here the sensor has collected some data in the form of a physical variable like temperature or position or force. So this value, this physical value is converted into electrical voltage with the help of a transducer. So there are two components of any measuring device. It will process the information, it will send the data back to the control system. Now, so we have seen that the sensor has two types of signals. It can produce continuous signals or discontinuous digital signals. So here the continuous signals are analog, in the form of analog, and digital signals are binary in the form of binary signals like ones and zeros. Okay. So we'll see what are the different classifications of sensor. So sensors are mainly classified into two types. First one is analog and second one is discrete. See here, the measuring device produces a continuous analog signal such as electrical voltage. Then the sensor can be called as analog sensor. It produces an analog output. Like the best example for this is thermocouples, strain gauges and potentiometers. Now see here, thermocouples is generally used for measuring the temperature difference. And strain gauge is very important as in the point of aeronautical or mechanical engineering point of view. Strain gauges are very important because strain gauges can measure the strain with which we can calculate the stress in a body. Okay, and then potentiometer is another important device which can measure the position of the machine. Okay, it can calculate how much rotation it has moved or how much distance it has moved. So the position can be measured with the help of a potentiometer. Now Here strain gauge. Strain gauge is an important thing. We have to discuss a little about the strain gauge. Now see, the strain gauge is a mechanical device which can measure the strain in a body. Suppose I have a metal body. I have a metal rod, cylindrical rod. On this cylindrical rod, I have placed a strain gauge. Now I am applying some tensile force on this cylindrical rod. Now what happens is the strain gauge will expand along with the metallic rod. So whenever I apply some force on this rod, what happens? This rod will expand. Very small deformations will be caused to the cylindrical rod. And whenever the strain gauge is attached to the cylindrical rod, so the strain gauge will also elongate with the cylindrical rod, the base rod. So what happens is this will measure the deformation. This will measure the deformation and it gives the value of delta. Now this delta can be used for calculating the strain. We have the formula for strain. Strain is equal to change in length by original length. Delta L, change in length by original length. Delta L by L. Now this delta L is used to calculate the strain, and this strain in turn it is used to calculate stress. Generally, what is the formula for stress? So stress is nothing but load by area. So here we have a cylindrical rod. When we are applying some load on it, that can be written here in the numerator, and in the denominator we have cross-sectional area. Now there is no machine so far developed for calculating or measuring the stress in a body. Suppose in this example I have a cylindrical rod where I am applying some force on both sides, which is tensile force. Now whatever the deformation I can calculate, but I cannot calculate the stress inside the body because stress is invisible. Directly we cannot measure the stress value. So this stress, with the help of deformation, in turn with the help of strain, we can calculate the stress value. Now we have a relation Young's modulus E is equal to stress by strain. Stress divided by strain. Now here we have a standard Young's modulus value, which is capital E. It is the property of any metallic rod depending on the metal. And strain we have calculated from the strain gauge. Strain gauge will give the deformation, and this deformation is used to calculate the strain. And the strain and Young's modulus are used for calculating the stress value. Okay. Now, these strain gauges are very important in mechanical applications as well as in aerospace aeronautical applications. So, for calculating stress, we will use strain gauges. Okay. And then, this is first kind of sensors, analog sensors, which produces a continuous signal like electrical voltage. Now, second type is discrete sensors. So, this system can produce an output that can have only certain values. Now, again, discrete sensors are two types. First one is binary and second one is digital. So, see, the binary sensors, it produces a on or off signal. Okay. With the help of this binary sensor, we can give two types of signals, whether we can close the circuit or we can break the circuit, on or off signals. And the best example for this is limit switches. Okay. And then second one, digital sensor. Digital sensor which produces either parallel status bits or series of pulses. Okay. It produces a series of pulses which can be measured and which can be taken as a feedback from the machine. Okay. So this signals can be directly given to the transducer, and this transducer will convert them into electrical voltage, and this electrical voltage is sent to the controller. And again at the controller, the electrical signal which has come from the sensor is again decoded into binary or a digital form, and it can be used in the controlling process. See here, there are some examples. For parallel status bits, photoelectric sensor is the example. This photoelectric sensor will produce, it can measure the it can measure the light light, how whenever the light is there or not, or this can be used to calculate the light sensitivity. Okay, so this signal is converted into parallel bits, and in the series of pulses, the example is optical encoder. Here in optical encoder, it is used for measuring the rotation of a body. Like this optical encoder is a disc which has some grates on it. Grates means slits. Okay, it has a lot of slits on the surface. So what happens is, on this surface, on one side we have a light source, on the other side we have a sensor. What happens is, from the light source, the light will come through the disc and it will fall on the sensor. Now, whenever the disc is rotating, the light position will change, or the light emitting, or the light capacity will change according to the position of the position of the optical disc. Now what happens is, it can actually measure with the correct calibration, it can measure the rotation of the disc. Okay, so this calibration, that entire thing is we will discuss in the later classes when we are studying optical encoders in robotics. So these are the two types of sensors, analog sensors and discrete sensors. Now we'll see some of the features of sensors. What are the important features any sensor should have while we are selecting a sensor? Like, for the particular purpose, which kind of sensor we need. So that can be selected from these features. So the first one is high accuracy. Any sensor should have very high accuracy, because it should be in a position to control the system with this feedback from the sensor. Okay. Now, if this sensor has any errors which are more than the given value, so then the system will fail because the sensors are not working properly. Okay. Now, small system errors should be avoided. Okay. For any sensor, the high accuracy should be there. And then second one, high precision. The precision of the values given by the sensor should be very high. Okay, the variability of the values should be very low. So that is how the sensors will be used better. And then third one is wide operating range. Should be working over a wide range of physical variables. So suppose if I take a sensor, this sensor, if it is used for only one kind of a variable, like I take an example of thermocouple, it will measure the temperature only. It cannot sense any other parameters. So this should be avoided. If I take a sensor, it should be able to measure more than one parameter at least. Okay, it should be working over a wide range of physical variables, and also it should cover a wide range of the parameter value. Suppose I have a thermocouple which can measure the temperature up to 100 degrees centigrade. I cannot use it anywhere, because that thermocouple should be capable enough to measure any temperatures ranging from like minus 100 degrees to plus 1000 degrees centigrade. It should have a very wide range of measuring variables. And then high speed of response. Now see here, whenever we are using a sensor, we will use the sensor for measuring the output parameters. Whenever the measurement of output parameters is done, this measuring should be very fast. There should not be any lag while measuring the parameters. So that we can use the sensors in an effective way. Okay, because we are sending this information, whatever the output variables are there, those data should be sent back to the controller in order to change or modify the program accordingly, so that the control system will work better. Now, next one is ease of calibration. Calibration should be quick and easy. Now we have seen already what is a calibration. Calibration is nothing but we have to calibrate the system according to the physical parameters of the manufacturing unit. Depending on the particular machine, a sensor should be calibrated. Like we have to check whether the sensor is actually measuring the predefined value. Okay, so this calibration should be done for every sensor which is placed on any machine. So the calibration should be easy and quick. Okay, so we should not take more time for calibration. And then minimum drift. So the gradual loss in accuracy should be low over the time. When we are using a sensor for longer period of time, like I will fix a sensor in a refrigerator and I will use the refrigerator for like 10 years. So after the time is passing, like after 10 years, the sensor should be perfectly working to measure the temperature so that it does not cause any malfunction in the refrigeration system, because a refrigerator does not work properly if the temperature measuring unit or the thermistor does not work properly. So that is why the sensors should be designed in such a way that they should be lasting longer periods. And then high reliability. So any sensor we have taken, this sensor should be very reliable. Whatever the information given by the sensor should be reliable, because any wrong signal from the output parameters given to the sensor, this sensor information is taken to the controller, because any wrong information will cause the entire machine failure. Okay, so high reliability should be there. And finally, low cost is what any manufacturing unit requires. Low cost of the sensor is required so that the economy should be very reasonable when compared to machines which does not have any sensors. Okay, we have different types of sensors. We'll see some of them here. So here are some of the measuring devices which are also called as sensors. These are the sensors used in automations. Now we'll see, first one is accelerometer. Accelerometer is a device which will detect vibrations or shocks in any machine. Like these are mostly used in aeroplanes or space satellites. So accelerometer, these are mostly nowadays being used in the mobile phones also, where we will use an accelerometer sensor, gyroscopic sensor. All these sensors are used in mobile phones nowadays. So these sensors are used for calculating or measuring the vibrations of the device. Whenever there are more vibrations in a body, they can cause entire machine failure, vibrations and shocks. And then second one is ammeter. So we all know ammeter is a device which can measure electrical current. Okay, this is another type of a sensor. And then third one is DC tachometer. Now see, the tachometer is a device which will measure the rotational speed. So this rotational speed will be measured with the help of a tachometer. It will use some kind of a light, infrared light it can use, and this light can be used to detect the speed of the rotating body. And then dynamometer. So dynamometer is another device which can measure the force. With the help of force, we can calculate other parameters like power or torque. Okay, so this dynamometer can be used to calculate force. Okay, and then fifth one, linear variable differential transformer. So this is commonly known as LVDT. This LVDT is used for measuring the force or pressure. Whenever there is a system, if we want to calculate the pressure which is applied on the system, then we can use LVDT, linear variable differential transformer, for this purpose. Whereas in this LVDT, the pressure is directly converted in the form of a signal, electrical signal, and this electrical signal can be given to the controller. So the LVDT is used for force measuring or pressure measuring. And then sixth one is strain gauge. We already know that the strain gauge is used for measuring the strain. In turn, the strain can be used to calculate force, torque, or pressure. Okay. And then seventh one is limit switches. So binary contact sensors, push button closes or open a circuit. So these are the different types of limit switches that can be used in controlling systems, where we can use the information from these sensors and we can manipulate the actuator. Now, another important thing we are discussing in today's class is actuators. Now we'll see what is an actuator. So some other sensors are there before going into actuators. Like we have manometer. So manometer is a device which is very commonly used in measuring the pressure, where we can measure pressure of the liquid or gas. And then second one is ohm meter, which will calculate the resistance of electricity in the form of electrical resistance. We have a device with a ohm meter. And then third one is optical encoder, which will measure the position or speed of the moving body. Okay, optical encoder we will see in detail in the coming classes. And then photoelectric sensor. Photoelectric sensor is nothing but it is a binary non-contact sensor for light beam break. So photoelectric sensor is a device which can detect the light and it can send that information in the form of electrical signal, whether there is a light or when there is a light break. Okay, so this is mostly used in optical encoder, where we will use a sensor for measuring the rotation of the body. And then potentiometer. Potentiometer is a device which is used to increase or decrease the resistance depending on the position of the sliding part on the potentiometer, where we will use this potentiometer for measuring the resistance. This is in turn used, it can be used for measuring the position also. And then sixth one is thermistor. Thermistor is a temperature measurement based on resistance of a semiconductor device. So the thermistor will use a semiconducting material which will measure the resistance, which will measure the temperature based on the resistance. Okay, so thermistor is used for measuring the temperature of a body. And then thermocouple. So thermocouple is a device where we will use two metals, where the elongation of these two metals can be compared and this information is converted into temperature difference. Okay, so in thermocouple there is a couple of materials or two metals we will use. These two metals, when they are subjected to temperature, either cold or hot, so they will these two metals they have different properties. That is why they will react differently to the temperature. One metal will elongate more, other metal will elongate low. So this difference is used for calculating the temperature of the surrounding, where the thermocouple is used. So this gives an analog temperature measurement. Thermocouple will give the analog temperature measurement. And then these are some of the sensors which are used in automation. Now we'll see what is an actuator. So in any robot or any automated system, we will have some parts like sensor, actuator, and actual working tool. Okay, some controller is taking the information from the sensor. This actuator is what will make the machine move. It can move the machine like in linear or rotational. Okay, so the actuator, it will takes the signal from the controller and it converts that into physical parameter. We have the definition here. It is a hardware device which can convert a controller command, whether the controller will be sending some controlling signals, whether linear motion or rotational motion. This kind of information will be sent by the controller. That signal is converted into a physical parameter. Like it will give a small signal at very low value. Okay, what this actuator will do is it will convert or amplifies the signal and it will make the machine move. For this we can take the best example is a robot. The robot will have this is a base and the robot will have now this is a robot and these are robotic arms and it will be connected with the help of joints. This is robotic base. These are links and the end one is end effector. So these are some of the parts of a robot. We will see in detail in the coming next classes. So what happens is whenever this robot is given an instruction to move from point A to point B, what it will do is it will take the signal from the controller and the signal is converted into physical form with the help of an actuator. Here we can see there are different joints are there. joint 1, joint 2, joint 3. So what happens is all these joints will have some actuators. Whatever these actuators will do, they can create linear or rotational motions. Okay. So the linear motion or rotational motion which is caused by a device, that device is called as an actuator. Okay. Now these actuators are placed at joints J1, J2, J3 in order to create any kind of motion. Mostly they will use rotational motion. Rotational, and sometimes they can use linear motion also. Okay. Now in this robots we can use the actuator to move the robot from point A to point B with the help of actuator. Whenever we give a signal to the actuator, it will switch on, it will create some rotational motions, and this rotational motion will move the robotic arm from one place to another place, from point A to point B. Now, this is the basic definition of a actuator. It is a hardware device which can convert the controller signal into physical parameter. Mostly, it will convert the signal into mechanical movement. So the command signal is of very low, hence actuator will amplify the signal. This is already discussed. There are different types of actuators: electrical, hydraulic and pneumatic. Now we will see all those in detail. So see here, electrical devices, electrical actuators like DC motor, stepper motor. So these are some of the examples of electrical actuators which are being used in the automation. So when we are discussing the actuators, they are used in automation. So the automation includes both CNC machines as well as robots. In CNC machines, the actuators are used for loading or unloading the workpiece from the chuck of the machine, whether it is a drilling machine or a milling lathe machine. In robots, the actuators are actually used for creating the mechanical movement. Okay, so depending on the purpose, depending on the rotation or depending on the linear motion of the body, we can use different motors. Like in electrical, DC motor, stepper motors are there. DC motors are used for creating rotational motions, and then stepper motors are used for creating the particular angle. Like it can rotate from 0 degrees to 90 degrees or 0 degrees to 45 degrees depending on the signal given to the motor. And then we have hydraulic actuators. In hydraulic actuators, the best example is hydraulic piston. So what happens in hydraulic piston is the hydraulic oil which is stored in a tank. This hydraulic oil is pumped with the high pressure into the cylinder. Now this cylinder will have a piston. Okay, now the cylinder will have a piston. The oil is sent into the cylinder with high pressure. What happens is it will push the piston towards left side. Then this can be used for creating linear motion. If we make the oil flow through the piston, it will move in one direction. If we remove the oil from the cylinder, and it will move in the reverse direction. So this hydraulic piston is the arrangement where we can create linear motions. So hydraulic actuators are nothing but hydraulic piston arrangement, cylinder piston arrangement, where we can create linear motions. Okay, to and fro motions we can create with the help of hydraulic pistons. Here we will use compressed oil, which is stored at high pressure. And again, in pneumatic actuators are also works in the same way as the hydraulic actuators, but they will use compressed air in the place of compressed oil. Okay, pneumatic actuators will use compressed air, and the remaining working is same. Whenever we make the compressed air flow into the cylinder, it will move the piston in one direction. If we remove the air from the cylinder, it will move in the reverse direction. So that the hydraulic and pneumatic actuators can create only linear motion, whereas electrical actuators can create both. Mostly it can create rotational motion. Okay, whenever we want rotational motion, we will use electrical. If we want linear motion, we will use either hydraulic or pneumatic, depending on the surrounding and the application of the machine. Okay, the surrounding places of the machine also comes into picture when we want to use a hydraulic piston or a pneumatic piston, because hydraulic pistons can be used anywhere, and hydraulic pistons are more reliable when compared to pneumatic pistons. Okay, why? Because hydraulic pistons will use hydraulic oil which is stored in a closed tank. Entire thing is closed, there is no place to leak. Okay, and we can clearly see when there is a leak in the hydraulic system. Okay, because the oil will be coming out of the system. So hydraulic systems are more reliable when compared to pneumatic, because in pneumatic systems the air may leak from any point and we cannot observe, or we cannot detect the leaking of the air from the pneumatic system. And one more thing is, if we want to create a force in hydraulic systems, we can create the force gradually, like from we can gradually increase the force and we can make the object move. But in compressed pneumatic air, in pneumatic actuators where we will use compressed air, whenever this compressed air is made into the flow into the cylinder, this piston will move instantly. It cannot move slowly. The piston will move rapidly, so that it will create a jerk motion or shock motion. Okay, and another thing is, comparing the hydraulic and pneumatic actuators, hydraulic are more reliable because the failure in hydraulic system is very low when compared to pneumatic systems, because whenever the air leaks, the piston inside the cylinder will immediately go back to its normal position, which will cause sometimes some problems, or it may cause us a machine failure. Whereas hydraulic systems, the failure is very less and they can carry more weights when compared to pneumatic. So hydraulic are the best, because that is why hydraulics are mostly used in the earth moving machines, like JCB machines are there, where we will use hydraulic oil only. There we will use hydraulic actuators. And then let us see some of the examples of actuators. First one is DC motor. So here the DC motor can create rotational motion, where it will use DC electrical power. It will use direct current. Okay, the DC motor is one thing which can create rotational motions. And then hydraulic piston. The hydraulic piston mostly creates linear motion only. It does not create rotational motion anywhere. It will use hydraulic pressure of the oil. Okay, so this works on the principle of Bernoulli's principle, where a small amount of oil can be used to create a large amount of force. The entire thing is discussed in the fluid mechanics, where a very small amount of force applied on a liquid or a fluid can be converted into a very large amount of a force. So this relation was given by Bernoulli's. So based on this Bernoulli's principle, the hydraulic actuators will work. So hydraulic piston is one example of an actuator which can create linear motion. This is rotational motion, this is linear motion. And then third one is induction motor. Induction motor is using an alternating current, and it can create rotational motion. Okay, and then pneumatic cylinder. So the pneumatic cylinder is it also works on the principle of Bernoulli's theorem, and where it will use a piston cylinder which can cause linear motion. So here compressed air will be used for creating the motion. And then stepping motor. So stepper motor will use electromagnetic motor, where it can cause rotational motion. We have already seen the rotational motion is depending on the signal given by depending on the electrical current passing by the electrical motor. So the stepper motor will rotate in steps, like it can create certain, it can rotate through an angle. And then solenoid. So two position electromagnetic motor will be used in solenoid, where it can create linear or rotational motion. Mostly this can be used for creating the linear motion, and in sometimes it can be used for rotational motion also. Okay. And then relay switches. Relay switches are nothing but they act for on and off positions, which will opens or closes the circuit. So this on and off positions or actions will be managed by electromagnetic force, which is generated in the relay switch. Okay, these are some of the actuators which are used in automation. So in the next class we will discuss about the robots. We will study how the robots will work. What are the different components of robot? What are the classifications of robot? Okay, we'll see the anatomy of the robot. So we'll discuss the robots in the next class. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.